everybody. I am really excited to be introducing our invited speaker, Associate Professor Patricia Lockwood. Patricia's interests are in the area of social decision making, which of course at this current time, how we make decisions that affect us and others is really present for all of us in so many areas, and particularly areas that we saw already today in terms of peace, in terms of climate change, in terms of health, mental health. So a highly exciting talk. But we're in safe hands. Patricia's career started in University College London, where she studied her PhD, and she went on to Oxford as a research fellow. She's now an associate professor at the University of Birmingham, and she is the director of her lab group there, that is the Social Decision Neuroscience Research Lab Group. And also she's an avid cat lover, as self-identified on X in my following of her work. Really excited to hear all about your research today. Thank you.
Thank you so much for the lovely introduction and the very kind invitation to be here. I've had a really lovely day so far. So thank you so much for having me. I really enjoyed the talks this morning. We've already heard a little bit about some of the concepts that I'll be covering today, so things like prosocial behaviour. And I think that these are really important because, as we've really kind of thought about as well, these prosocial behaviours, which we can simply define as these decisions that we make that help another person, are really crucial for maintaining our physical and our mental well-being across our whole lifespans. They also have the potential to perhaps help to solve some of these global challenges, things such as climate change, infectious disease, ageing populations, and global conflict. In order to try and help alleviate the impact of them, we need to be prosocial, and we need to be willing to make decisions that help others. But one troublesome thing about prosocial behaviours is often they're quite effortful, and we know that humans in general find effort quite aversive. So how willing are we to help other people? Do we have specific neural systems in the brain that we might use to make those prosocial decisions? And how does our prosocial behaviour change across our whole lifespan? Are we equally as prosocial when we're in childhood compared to young and older adulthood? And to answer some of these questions, my research takes this kind of computational modelling approach to understanding prosocial behaviours. So it's perhaps a bit of a different approach, but I think what's really useful about it is that it can allow us to connect these different levels of explanation. So obviously it can't tell us everything, but it can be very useful for these levels. So in this framework that we recently proposed in answering whether there is a kind of social brain or whether we have these regions specialised for social behaviour, we suggested, drawing on the work of David Marr, that we really need different levels to answer this. So first of all, we need to understand the computation, or the why, or the goal. And we heard a little bit earlier about how goals might change how we navigate an environment. So I think this goal level is very interesting. And here the goal that we're trying to understand is prosocial behaviour. The second thing that we need to understand is the algorithm, or the kind of rules by which we actually use to solve this computation. And of course, there's going to be lots of different types of algorithm. What I'm showing here is just some equations, which I'll go through later. But I'm going to suggest that these two are really important. So first of all, effort discounting. So here what we're trying to do is to compute the subjective value, so SV. So this is like, do I perform an effortful action or not? And that's based on the reward that we might get, or the R, but that's devalued by the amount of effort we have to put in to do it. The second algorithm I'm going to talk about is associative or reinforcement learning. So here, rather than we're making an individual decision, what we're doing is tracking over time as part of our learning how valuable doing something is. So if I get a good outcome, do I want to make that same decision again? So these two algorithms actually come from non-social decision making, but I'm going to argue that they could be very important for understanding social behaviour. So the third level that we need to think about is then the implementational level, so the kind of like how, or the physical instantiation in the brain. And again, it's been argued that lots of different parts of the brain might be important for social cognition and behaviours, But here I'm really going to be focusing on these two regions. So area 24 in this ventral anterior cingulate cortex here. And this is quite different from this higher up region here, which is often associated with decision making, but also this subgenual anterior cingulate cortex area, or area 25. So why I think the brain anatomy is important is we know that these different parts of the brain have different patterns of connectivity to other parts of the brain. So understanding where somewhere is can actually help us understand more about its function. So I think that's really important. And on the right-hand side here, what I'm showing is also these same areas mapped in a non-human primate brain. So then we might be able to integrate some of our knowledge across species to really understand what's going on. And in this framework, I argue that we might have different dissociations at different levels. So whether a behaviour or an implementation is social or non-social could happen at the level of algorithm or the level of implementation. So that's a kind of overview of the framework. I'm going to be talking about prosocial behaviours and the algorithms and implementations that we might use to understand that. So in the talk, I'll cover three main questions. So first of all, how willing are we to put in effort to help another person? And how are those algorithms implemented in the brain? Secondly, how do we actually learn to help other people? And how are those algorithms implemented in the brain? And third, are there actually any differences in this prosocial effort and learning across our lifespan? And if there are differences, are they consistent around the whole world? Okay, so to set us off in thinking about prosocial behaviours, I thought we'd play a few games with the audience, because that's always fun. We can find out how prosocial we are and hopefully not judge each other afterwards. So what we're going to do is we're going to play the dictator game. So you're probably familiar with this, but in case you aren't, I want you all to imagine that I've given each of you £10 or €10, okay? And you have a very simple decision to make. You have to choose how much you would give away to an anonymous other person. You're never going to meet this person, and they won't know that it was you that made this decision. And you can choose to keep all of the money for yourself or give a portion of it away to this other person. So what I want you to do is just put up your hand based on what you think you would do, okay? So who would give the whole £10 away to this anonymous other person? 9? Couple of people for 9. 8. 7. 6. 5. 4. 3. 2. 1. 0. Great, don't feel embarrassed. So now what I'm going to show you is what happens if we ask 20,000 people that same question. Did they behave like this audience behaved, or did they behave quite differently? So this is a meta-analysis of dictator game behaviour, and those few people who bravely put up their hand for 0, don't worry, because probably if I did this in a room where you couldn't see each other's choices, that's exactly what would happen. So in this meta-analysis, 36% of people would give nothing away to the anonymous other person. So that is really the most popular option, and it suggests when we make an economic decision, perhaps we're quite selfish. That's not a judgment by using that word, but generally we want to keep this money for ourselves that is self-benefiting. After a lot of very unpopular options, we can see that give away exactly half, about 17% of people will do that, and that was really nicely represented by this audience. When we got to give away half, lots of people put up their hands. And that's suggested to be because people have specific preferences for fairness and equality. Great, so yep, we saw exactly half, so that suggests that people have these kind of social preferences. And then finally at the end, we have this tiny little patch here, and actually no one put up their hand here, but we did have one person at 9, I think. So about 5% of people give all of the money away. So what this suggests is that when we make an economic choice, as I mentioned, perhaps we're quite selfish, we want to keep the money for ourselves. But now we're going to make one more type of decision and see if that changes our behaviour. So now imagine that you've come to my lab and I've hooked you up to a very painful electric shock machine. And I've given you lots and lots of electric shocks because I'm a bit mean, until you say I don't want another one at that level. Okay, and now you have another simple decision to make. Do you want to go for option A? I'm going to give you a £10 note, but you're going to have 7 more of those electric shocks. Or do you want to go for option B? I'm going to give you more money, I'm going to give you £15, but you're also going to have to experience a few more of those shocks, so 10 shocks. So who would go for option A, less money, less shocks? Maybe about half. And who would go for option B? Yeah, it's about 50-50, isn't it? Great. And now you've got your final decision to make. So now, same choice, but this anonymous other person is going to get the electric shocks. And you get to keep the money. So now who would go for option A? Less money, less shocks. That's quite fun. Option B. Yes. Very good. So that's exactly what is very replicable. You can do it here, you can do it in the lab. So what Molly Crockett and Oriel Thelman Hall and colleagues have shown is once you frame it as this kind of perhaps more moral choice, or it's about actually causing harm, suddenly people seem to care more about the outcomes for the other person. So they kind of have this higher harm aversion parameter for other compared to self. And that's all the blue people here, but you can see there's still some people who prefer self over other. So as I said, what this suggests is when you're making this kind of moral choice, perhaps suddenly you're hyper-altruistic, you care more about outcomes for other people. But of course we know in everyday life, it's very rare that you have to just make a decision to give money away to someone or whether you want to give them electric shocks. Instead, what we have to do is we have to decide whether we're going to put in effort. And theoretical accounts of motivation suggest that we do that by having this cost-benefit analysis, where we weigh up the positives or benefits, or the rewards that we might get, versus the negatives or costs, so the amount of effort that we have to put in to get it. And this account is not just theoretical, because we know there's actually single neurons in the frontal cortex of the macaque monkey that scale their firing rate with the amount of physical effort that you have to put in to get a reward. So these code that kind of subjective value, often effortful action. And when we make an effort-based decision, there's really 2 choices. First of all, do we decide to do it or not do it? And secondly, we then need to decide whether to actually energize our actions to the right degree. So, sometimes we can say we're going to do something and not actually follow through with it. And here what we wanted to ask was what happens when we contrast this to a prosocial decision? What happens when we actually have to put in effort to help another person? And is it more like this kind of dictator game behaviour where we're quite selfish? Or is it more like this harm aversion behaviour where we care more about putting in effort to help other people? So to do that, in this first study, we tested 39 young adults and they were aged 18 to 36. And we did this kind of slightly weird setup that we use in most of the studies that I'll talk about today. So we get 2 people to stand either side of a door, and they're wearing this kind of weird washing up glove, and they just simply have to wave to the other person. So the reason that we do that is we really want to make sure they know another person is there, that they're going to play the games for, but that person can't see any information about their appearance, their age, or their identity. So after we've done the weird washing up glove thing, we then asked one of them to go in an fMRI scanner, and we also got them to squeeze this hand grip device as hard as they could. So that measured how much strength that they could put in, so that all of the choices we gave people were actually calibrated to their own ability. So then we asked them on each trial in our experimental paradigm to make a decision between 2 options. So on each trial, they could either choose to rest, they weren't going to have to squeeze this grip force device, but they'd only get a very low amount of rewards. They'd only get 1 credit, and all the credits are converted into money at the end. Or they could alternatively choose this work option, if I can get the mouse, and this work option was always going to be more credits, but they'd also have to put in more effort that was signalled by how filled in the pie chart was. Importantly, on half of the trials, they made these decisions for themselves. They chose between the 2 options, they exerted the physical effort, and they got the credits. But on the social trials, They had to choose between the two options, they had to put in the physical effort, and this other person that they met at the beginning would get the credits. So they played this for lots and lots of different rounds where we could manipulate the effort level and the reward level independently. So using this paradigm, we could ask two questions. So first of all, are people equally willing to choose to put in effort to reward themselves and the other person? And secondly, are there actually specific brain areas that code for this prosocial effort decision that are not there when making this self-benefiting effort decision? So to answer that, we first did some fancy computational modelling, which is actually not that complicated, but a bit boring to explain, so I'll keep it quick. So we basically calculated this K parameter here that's shown in the kind of teal. And what that does is it just indexes the subjective value of how motivated people are. So if you have a very high K parameter, that is these kind of blue people here. So that means very quickly you don't want to do something. As the effort level goes up, you're like, I'm not going to do it. But if you're one of the people here with this more black line, you can see as the effort level changes, you're still always accepting the offer. It doesn't really change your behaviour. You're like, fine, I'll do it. It's more effortful. So if you have a very low K parameter, that means you're very motivated. And if you have a very high K parameter, that means you're much less motivated. So first we can look at the choice behaviour. And you can see that what we found was that as the effort level went up, people were much less likely to want to do it. So this is plotting the proportion that they accept that work offer over the rest offer. So you can see that as effort level goes up, they're less likely to want to do it. But we also found this kind of recipient interaction. You can see when it comes to helping the other person, they are still willing to do it at the highest effort level, but they're much less likely to. And we can collapse all of that complicated reward and effort level by simply plotting that K parameter. And here you can see people seem to have a much higher K parameter when they're deciding for the other person compared to self. So they are willing to be prosocial, but they're much less motivated to put in effort to help others than they are to help themselves. Because we have this quite condition-rich design, we could then look at some of the neural signals and we could try and map them in this multi-dimensional space. So what we did was we used a technique called representational similarity analysis, and here it's just a kind of example of how it works. So this is just a matrix of the different effort levels and how much they correlate with each other. So the very kind of yellow bit here is because this is the correlation between effort level 2 and effort level 6, and you can see they're very uncorrelated, so they're very dissimilar. So we can actually put that pattern on the whole brain and say, can you show me parts of the brain that correlate with that multi-dimensional pattern? And when we did that, we found that the only part of the brain that specifically coded prosocial effort rather than self-benefiting effort was this region in blue in the anterior cingulate gyrus. So that was really cool because this was a region that we thought might be involved in the study, which I'll explain a bit more in a second. But it had this very specific pattern. You can see it positively signals the prosocial and not the self. When we looked at the time of when people actually put in the physical force, again, we saw this anterior cingulate gyrus region, and now it was scaling with how much force you had to put in to help the other person, but not how much force you had to put in to help yourself. And if we look at other non-human animal studies, the fact that it was specifically this anterior cingulate gyrus region is really interesting because other researchers have shown that lesions to this ACCG specifically disrupt social behaviour. And we also have single neurons in this area that actually respond only when another monkey receives a reward and not in any other conditions. So that's in the same anterior cingulate gyrus region. So thinking about how the medial prefrontal cortex is organised, as I mentioned, there's also this anterior cingulate sulcus region that's a bit higher up and has quite often been involved in social cognition and in decision making. But when we saw what happened there, we found it did respond, but now it responded both to other and to self. So it was tracking everything that was happening when you made this effort-based choice, but it did in exactly the same way for self and for other. So as well as these distinct neural representations in the anterior cingulate gyrus, we have these more domain general ones in the anterior cingulate sulcus. So this suggests that using this task that very carefully separates self and other, we might be able to identify some very specific parts of the brain that could be involved in prosocial behaviours. So next we wanted to ask, how do we actually learn to help others, and how are those algorithms implemented in the brain? Of course, when we're making decisions, it's not about making these kind of one-shot choices, but we also need to learn from the feedback. Did we actually help, or did we avoid harming the other person? And again, we can kind of look to general cognitive neuroscience for a framework for how we make these decisions. So there's been quite a lot of work suggesting that these reinforcement learning or associative learning type algorithms are very good explanations of how we learn to obtain rewards over time. So here again, we're looking at subjective value, or SV, but now what's happening is we're changing the subjective value based on the outcome that we get. So when we choose an option, do we get a reward? And importantly, we've got this prediction error. So the prediction error here suggests that it's not just the reward that you get, but how unexpected the outcome of that decision is. So it's really reward expectations that drive our behaviour. And just like the K parameter, we also have this model fitted parameter, which is the learning rate. And the learning rate just changes how much influence the prediction error has on our choices. And again, like with effort-based decision-making, we can kind of look to basic neuroscience to see if there's parts of the brain that code these signals. And this is just showing some of the seminal work by Wolfram Schultz and colleagues that showed that you get these kind of dopamine-dependent prediction errors in the ventral tegmental area. So what they did was they recorded from the ventral tegmental area, and they did experiments where rewards were not predicted but then unexpectedly occurred. And you can see that that really increases the firing rate, and that's just like a positive prediction error. I didn't think something good was going to happen from my choice, but it did, so then there's a big response in the brain. They also showed that these dopamine neurons can signal these kind of negative prediction errors, and these happen when you make a choice and you really think you're going to get something good, and actually it doesn't happen. And when that happens, you can see the neurons really suppress their firing rate. So that's consistent with this negative prediction error. So we wanted to say, can we kind of use this framework to understand prosocial behaviour? And when we think about what parts of the brain might be involved, again, we might think of this anterior cingulate gyrus region because we saw it was involved in the prosocial effort, but also in this subgenual anterior cingulate cortex region here. So we asked the question, can we use associative learning theory to understand how we learn what actions will benefit other people? And again, are there these specific neural computations that don't occur when we learn about rewards that benefit ourselves? So here we designed this prosocial learning task. Again, we had 2 people come to the lab. This time they did actually meet face to face, but we said everything that happens will be anonymous. So the person outside of the scanner won't know that you're making these decisions for them. The other change that we had was we also had this kind of control condition. And in the control condition, we said sometimes you'll be playing for no one. So neither of you is going to receive the reward. And that's because there might be some parts of the brain that just care about not me. So it might look social, but it might actually just be like, okay, this is a signal that I'm not getting something. So then we gave them this very classical reinforcement learning task, where they were presented on each trial with 2 different pictures. So these abstract pictures were probabilistically associated with rewards. So one picture always had a very high probability of reward, and one picture had a low probability of reward. So people just had to pick these by trial and error and figure out which was the better option. So they made a choice, and then they saw the outcome of their choice, which was either win 100 points or win 0 points. And that meant that at the time of the outcome, we could calculate this prediction error. Because we were using probabilistic symbols, we could use our computational model to say how unexpected is this outcome when you make a choice. And on the self trials, again, we told them all of the points will be converted into money for you. On the prosocial trials, we told them all of the points will be converted into money for this other person that you're playing for. And in the control no one condition, we did this by saying you're going to see the points, but they just won't be converted into money, either for you or for the other person. So this task allowed us to look at a few things. First of all, this learning rate, which, as I said, is just like the K parameter. Because it's multiplied by the prediction error, it just means that the prediction error is having a slightly different effect on your behaviour. And when we looked at the learning rate in each of the three conditions, what we found was that people had a much higher learning rate for their own reward outcomes than when they played the prosocial condition or the no one condition. So that suggested that they were maybe more interested, or the recent history of rewards were much more powerful when they were learning to benefit themselves than when they learned to benefit another person or no one. So then we can also take those trial by trial prediction error signals and we can have a look at what's happening in the brain. So as I said, this is at the time of the outcome. We can fit a single number trial by trial and correlate that with brain activity and say, where does the brain activity go up and down every time you get an outcome? And what was really interesting there was, again, we saw a region in the medial prefrontal cortex, but now it was in this more ventral anterior cingulate cortex region, so this green little bit here. And it showed this really interesting pattern of behaviour because it positively responded whenever we made a choice that benefited another person, but it didn't significantly respond to the self-prediction error or even the no one prediction error. So it had this very, very specific signalling when we made choices that benefited another person. And again, what was even more unique about this area is this is not what the whole brain was doing. So when we look at other parts of the brain, in particular the ventral striatum, that's quite commonly associated with signalling prediction errors of rewards, we did find this area, but importantly, it tracked these prediction errors regardless of who got the outcome. So it's responding to the self, the prosocial, but also this no one prediction error that isn't actually associated with any monetary reward. And I think that's quite important because also lots of people say the ventral striatum is doing rewards, but here we kind of show it could be an actual reward or just points, and it's still signalling that response regardless of who gets the outcome. So following up on this work, we also wanted to see how robust these effects were in the subgenuine anterior cingulate cortex, and also whether we could also modulate them by pharmacological agents. So recently, in a collaboration with researchers at King's College London, they were interested to use our paradigm to look at whether oxytocin might actually modulate responses in the subgenual ACC region. So if you're familiar with oxytocin, there's been quite a lot of controversy about how it works. Some people said that it was like an amazing hormone that was going to make everyone lovely and social, and other people were like, no, it's just going to make them aggressive. But here we had this kind of very simple question where we had this self-benefiting and this prosocial benefiting condition, and we got people to play this game in 4 different sessions. It was a within-subject double-blind placebo-controlled design. And they did this task repeatedly in 4 different sessions, and they received one of 3 doses of oxytocin, so either 9, 18, or 36 international units, or they received a placebo. So we could also compare whether there was this kind of dose-dependent response of oxytocin to neural activity. And what I'm showing here is just the kind of way that it worked in terms of the phase of the task. And here we also don't have the no one condition just for logistical reasons. It was quite a difficult study to run. So what we found was indeed the subgenual ACC again seemed to signal these prosocial prediction errors on average much higher than the self-orientated prediction errors. But intriguingly, we also found this dose-dependent modulation by oxytocin, where it was really the low and the medium dose that had the biggest impact on higher signalling of prediction errors in this subgenual ACC region, suggesting that this general subgenual ACC effect is replicable, but also that it might be modulated by oxytocin. And in a final study recently as well, we had the opportunity to study patients who had focal lesions to the ventromedial prefrontal cortex. Normally these studies involve fewer than 10 patients, but we spent a long time collecting them in collaboration with a neurologist, and we were able to get 28 patients that had this quite focal damage. And what I'm showing here is just the proportion of lesion overlap. So you can see they really all had lesions within this VM-PFC region, and they didn't have lesions anywhere else in the brain. And we compared these patients to 124 healthy controls, and we tried to match them as closely as possible on things such as age and gender and this executive function task of trail making. And again, they performed this exact same prosocial learning task where they really had this anonymous procedure at the end where they saw another person was there. And this is work led by a PhD student in my group, Margot. Okay, so what did we find? Well, first of all, looking at how accurate they were in the task, we saw that just like with the first study we did just in young healthy controls learn better to reward themselves than another person or no one. So we saw that again. But when we looked at what happened in the VM-PFC patients, suddenly they seemed to have this quite specific impairment in prosocial learning. So they weren't able to learn significantly above chance at all when they were learning to benefit another person, and they actually learn equally as well for self and for no one. And because we had this large sample, we could also conduct lesion mapping to try and link what areas of the brain might be involved in this deficit in prosocial learning. And quite nicely, we found again it was this subgenual anterior cingulate cortex area, which I'm showing here on the right, where we showed through the lesion mapping if patients had damage here, it slowed their prosocial but not their self-benefiting learning. So this is kind of the third piece of evidence that this subgenual ACC region might be really important for learning to benefit another person. Okay, so I'll go on to the final question now. How long do I have left?
24 minutes.
Okay, cool. Lots of time. I did leave some time for questions at the end. Great. So finally, I wanted to talk a bit about whether these differences we see in prosocial effort and learning across the lifespan, whether they are really there, whether older adults behave in the same way, and if we do see any age differences, can we actually find that they're consistent around the world? And I guess what we've shown so far is perhaps younger adults are a bit more selfish in their decision making. So is that something that we see across the whole lifespan? Well, we thought this was an interesting question because if we look at other areas of psychology, there's already a bit of evidence that perhaps older adults might be more prosocial in their behaviours than younger adults. So first of all, if we take that meta-analysis of the dictator game, that game that we all played at the beginning of the talk, if you just look at the sub-portion of older adults in that meta-analysis, they actually give more money away in that dictator game. Secondly, we know that the connectivity and function of different social brain areas, if we want to call them social brain areas, seems to change as we age. So this recent study suggested that these areas highlighted in kind of red and greeny blue were the ones that showed the most change in their connectivity and function across the lifespan. And you can see they overlap quite nicely with that more like anterior cingulate region and this subgenual region. So that could kind of give us a biological reason for why there might be changes in prosocial behaviour and decision making as we get older. But one of the challenges in conducting this research is firstly, as you might have already thought when I showed you that dictator game result, is that older adults just might have more accumulated wealth. Is it that surprising they give more money away in the dictator game? The cost is just financial. And secondly, we know that often, but not all the case, older adults, if they're retired, they might have more time. So lots of paradigms used in social psychology use time as the manipulation for prosocial behaviour. So they're like, how many sheets of this difficult mathematical operations do you want to complete? So it may be that any differences that we see are just a factor of the experiment, but not a true reflection of behaviour in older adults. So this is where we thought that our paradigm might be quite useful here because the time commitment is very tightly controlled. Whether you choose to work or rest, you lose the same amount of time in the paradigm. And secondly, we can make sure that in this paradigm, the cost is not financial. you might be giving money to the other person, but the cost that we manipulate is how effortful it is. So we can look at whether older adults actually are more willing to put in effort to help another person. So to do that, we tested 92 younger adults aged 18 to 36 and 95 older adults aged 55 to 84. And I'm not making any comment on what is young and what is old. We call them younger and older. It's a relative definition. And we tried to match them as closely as possible. So we matched them on gender, we matched them on years of education. And importantly, this is a healthy aging sample, which is not something we can do when we do the big global data that I'll present at the end. Because they came into the lab, we could screen them for dementia and make sure that this was just normal, healthy aging. And of course, because there might be differences in physical ability across the lifespan or even within different groups, again, we use this procedure where we can threshold the effort level to their own ability. So all of the offers of effort, they might have 6 levels, but that will be on the basis of 70% of like their own maximum voluntary contraction. So again, they got the same paradigm that I presented before. They had to make a choice between resting or working, where they had to put in more effort, but they could also get a greater reward. And they sometimes made these choices to benefit themselves, and they sometimes made these choices to benefit this other person they'd met at the beginning. And importantly here, because we're using the glove procedure, they don't know how old the other person is. So we did ask them at the end, do you trust the other person? Do you like the other person? How similar are they to you? Obviously, we didn't give them really any information to try this, to think about it. And what we saw was that young and older adults rated the other person as equally similar to them. So we can't say whether they think they're old or young, but they just think they're similar. Okay. So are young and older adults equally willing to put in effort to reward self and other? So again, we can look at these K parameters, and if you remember, if you have a very high K parameter, that means you're much less motivated. And if you have a very low K parameter, that means you're much more motivated. So this is first of all just in the young adults, and we replicated exactly what we saw before. So people have a much higher K parameter for an other person. They don't really want to put in as much effort to reward them. And they have a much lower K parameter for themselves. So they're quite willing to choose these effortful options that benefit themselves. But when we saw what happened in the older adults, we saw quite a big difference. So now we saw that they were much more motivated to put in effort to help the other persons. There was a large reduction in their K parameter for other. And there was a small difference for self, but it was nowhere near as similar. But now you can see the self-other difference is also greatly reduced. So this suggests that the older adults had much greater prosocial motivation than the younger adults that we saw in our study. So the next thing that we can also look at, which is quite nice and perhaps more implicit in this paradigm, is how much they actually energize their actions once they've chosen to help. So first of all, again, looking at the young adults, what we saw was what we initially termed kind of superficial prosociality. So in the young adults, they would say they were going to help, but they wouldn't actually energize their actions as strongly at the highest effort levels. So they are still getting the reward, they're just kind of less motivated by it. But when we looked at the older adults, we saw this effect completely went away. So older adults were just as willing to put in effort to help themselves as for the other person. They energized their action to the same degree. And importantly, between the two groups, there wasn't a significant difference in how successful they were. So to be successful, you're getting this kind of real-time visual feedback of how much you're squeezing. This bar goes up and down, and you have to get it over this yellow line. And there was no difference in how successful the young and older adults were at achieving that, but they kind of show this difference in energization. So this is also consistent with older adults perhaps being relatively more prosocial and wanting to put in more effort to help. So the second thing we wanted to do was, again, to check this in the prosocial learning task. So there's different reasons why we might expect behaviour to differ here. So there's quite a lot of research now suggesting that older adults might be worse than younger adults at associative learning tasks, so these probabilistic reinforcement learning tasks. But as I've shown, they seem to be more willing to put in effort. So what happens when we give them this prosocial learning task where they have to learn to benefit themselves, another person, or no one? And this was work led by a postdoc in my group, Dr. Joe Cutler. So we tested here 75 younger and 77 older adults. Again, we tried to match them as closely as possible, and again, they completed this task where they anonymously met someone else at the beginning. So again, looking at the young adults, first of all, we again replicate that finding where they have a higher learning rate for their own reward outcomes compared to those for another person or no one. But when we look at the older adults, suddenly we don't see a significant difference in their self and other learning. But importantly, they are still able to distinguish self and other from no one, so they still have a difference between those. And when we put that all together, we can see that we actually find strong Bayesian evidence in support of no difference between self and prosocial learning in the older adults between the younger adults, whereas their self-learning rate difference does decline a little bit. So this was really interesting because it suggests that older adults kind of have this reduced self-bias in their reinforcement learning, and they learn at a similar rate for their own reward outcomes and reward outcomes for another person. So do we get more prosocial as we age? So in the final study, we wanted to kind of put this all together. So what I've shown is that older adults choose to put in more effort to help the younger adults. They also seem to learn at a similar rate to benefit others. And I've suggested that there might be these dissociable brain areas that are involved in prosocial and self-benefiting motivation and learning. But when you present this data, you often get a few questions. So the first one is, are older adults more prosocial to everyone? Weren't they the ones who voted for Brexit and for Trump? It doesn't seem very prosocial. How do you explain that? Secondly, are older adults more prosocial everywhere? So we might all be familiar with these weird populations. So in psychology, how we study populations that are Western, educated, industrialised, rich and democratic. So was this just because I did this study in Oxford and there's some very nice local older professors who wanted to come in and be really prosocial, but actually this is not what older adults around the world are doing. So we had the opportunity to test this during the COVID-19 pandemic as part of an international collaboration on the social and moral psychology of COVID-19. And again, this is work led by a postdoc in my lab, Dr. Joe Cutler. So as part of this collaboration, we were able to access the data of over 46,000 participants. They covered the whole adult lifespan from age 18 to 99. And we were able to have data from 67 different countries and territories. And what this map is just showing is the sample size that was collected in each country. And the brief was basically you need to be able to collect at least 500 people that are representative of the population in your own country to contribute data to this project. And what we thought was really cool about this project was that it had some measures that specifically related to some of the prosocial measures we were using in the lab. So first of all, it had a measure of donations that was framed just like a dictator game. So people were told, imagine you have your median daily income and you can choose to give some of it away to help victims of COVID in your own country. You can choose to give some of it away to helping victims of COVID abroad, or you can keep all the money for yourself. So you kind of have this three-way split like the dictator game, and they just had to choose any proportion of that three-way split. We also had a measure of distancing, and of course there's lots of reasons people distance. It was phrased in a way that was prosocial to protect other people, and actually the distancing and donations measures quite highly correlated with one another, which provides a bit of support that it was some kind of prosocial measure, but of course it is very challenging. And because it's very challenging, we tried to control for as many things we could possibly think of all the data we could have access to. So we controlled for perceived risk of catching COVID. You'd think that that would affect distancing. We controlled for people's physical health. We controlled for how subjectively wealthy they felt, as well as the actual objective country level wealth that was available on international databases. We controlled for COVID-19 severity in the country at the time. And we also conducted all of our analyses with age adjusted by life expectancy. So I think that's one of the biggest advantages of this data set is because around the world people have different life expectancies. it meant that we could decorrelate chronological age from age adjusted by life expectancy, and we could show that all of our results remained the same with either measure. And because we had the opportunity to actually pre-register this study, and because of how the data was collected, we did exactly that, and we hypothesized, based on what we were seeing in the lab, that older adults would be more prosocial, and that would mean that they would report greater donations and greater distancing. But based on just anecdotal evidence, as well as some work suggesting older adults are less supportive of foreign aid, we predicted that perhaps they would also be more biased in who they donated to. So they would have a greater preference to help the national versus the international charities. So first of all, are older adults more likely to donate and distance? That's exactly what we found. So what we're plotting here, we actually split the sample into two, but I'm showing the combined sample here, is that generally as age goes up, donations goes up. You can see it's a bit quadratic, so there was a bit of a dip. And in distancing, it was just linear. So as age went up, people were more likely to report distancing. And these survived for all of the different control measures that we had, and were robust to age adjusted by life expectancy. So yes, it seems they're more willing to donate and more willing to distance. However, are older adults more selective in who they donate to? And that's exactly what we found. So as age went up, although older adults overall were saying that they'll give away a greater portion of their income, there was a strong age by charity interaction. So you can see these national is always higher above international across all ages, but the gap really widens as people get older. And we did some additional work here showing that this gap was mediated by a sense of in-group preference, which combines national identity and collective narcissism and political orientation. So yes, as people got older, they were much more willing to give money away, but much more selective in who they wanted to give it away to. So finally, we wanted to kind of, these are just effects in 46,000 people, 67 countries. We wondered if that might hide some of the variation around the world, but we actually found that patterns were pretty consistent around the world. So what we then did is we plotted the effect size of the association between age and prosocial behaviour in each country that we had in our sample. So if it's more red, that means there's a positive association, and if it's blue, it's negative. So you can see for both distancing and donations, most countries in the world showed that positive pattern. And for those that didn't, there wasn't anything that really brought them together in terms of their kind of cultural history or their religious beliefs, for example. So it seemed really robust around the world. And when we looked at the negative effect of international donations in age, again, we saw that that was quite consistent. Again, there wasn't anything in particular that grouped together the three countries that did not show that pattern. So it seems to be very globally robust, these differences with age and prosocial behaviour. So to summarise all of that, what I've suggested today is that prosocial motivation might be related to specific brain areas, in particular the anterior cingulate gyrus, which seem to be associated with prosocial effort, so how much we're willing to put in effort to help others. Whereas I suggested this more ventral portion of the medial prefrontal cortex might be involved in prosocial learning, so how we make decisions and based on feedback decide whether we're going to help another person. I also suggested that perhaps humans might become more prosocial from young to older adulthood. And I showed evidence that older adults seem to want to choose to put in more effort to help than the younger adults we looked at. And also older adults seem to learn at a similar rate to benefit other people as they do to benefit themselves. I suggested that these age and prosocial effects are perhaps quite consistent around the world. We saw them in most countries, but also that older adults might show these kind of greater national preferences, a sort of perhaps in-group, out-group bias in who they want to allocate that help to. And at the moment, we're doing ongoing work in an even larger sample with a wider age range to look at multiple measures of prosocial preferences and behaviours. And I'd like to thank all of the many people involved in this work. This is my lovely lab on the left, and all of the collaborators in this work, the funders of the research, and of course you for your attention. Thank you.